one about quadratic number pattern. Okay, so we've got a quadratic number pattern that goes 5, 12, 29, 56. The first thing that they want us to do is they want us to write down the next two terms in the pattern. Okay, so how would we work out what they are? How would we know what the next two terms in the pattern are? Does anybody know? How would we work out what the next two terms in the pattern are? Is this a difficult question to work out the next two terms in the pattern?
Ma'am.
Yeah. Yes, Mr. Zuma.
Oh. That's what I was going to say, ma'am. What permits to say right now?
Oh, okay. Yeah, absolutely. Absolutely. So, you know, what you can do with on your calculus, I mean, the thing is that you don't actually need to, well, you can use that for 2.2 as well if you want to. So if you write down your 5, your 12, your 29, your 56, then working out your first difference is going to be term 2 minus term 1, which is 7. And then term 3 minus term 2, which is going to be 17. And then term 4 minus term 3, this is going to give us 27. So we can see that it's going up, all right, in 7 and then 10 more than 7 and then 20 more than 7. So the next one would have to be 56 plus 37 would be the next term. So 56 plus 37, sorry, I'm operating in the dark here, so you're just going to have to forgive me for being a little bit slow this evening. I can't actually see anything and I'm blind as it is, so when there's no power it's just even worse. Okay, so 56 plus, then it would be 37 in this case. All right, so the next number would be 93. And what would we need to add to 93? What would we need to add to 93, Matrix? Does anybody know? What would we add to 93 in order to get the next number in the pattern?
Ma'am, 47.
47, quite right. So 47 added onto 93 means that the next term is going to be 140. Okay, there we go. And obviously it would be 2 little accuracy marks on that. Good job. Okay, so now we can go back and we can finish off what it was that we had started over here, which was to work out the second differences. So 17 minus 7 would leave us with 10. And then over here, same story, 27 minus 17 is 10. So now when they ask us to find the value of the nth term, all right, of the pattern, we have to use formulae. All right, so if I want to work out the value of A, what formula do I use?
Ma'am, won't you have to say 2A equals to the, I don't know if it's the first difference or the second difference, but 10.
Okay, yeah, it's quite right. That's the second difference. Quite right. Okay, so we're going to take 2A and we're going to make it equal to 10. So that means that A is equal to 5. Good stuff. All right, now when we want to work out B, what formula do we use?
Ma'am, you're going to have to say A plus B equals to 7, and then you work out B, which will give you 2.
No, I'm afraid not. Okay, so the formula that we're going to use now, no, I'm glad you said that. Okay, so we use this formula. It's 3A plus B. Okay, 3A plus B has to be equal to 7. Okay, so now we're going to substitute in our 5. All right, and that means that B is going to be equal to -8. Okay, so very, very, yeah, quite right, Makusandile. All right, 3a plus b. All right, and now when we want to work out c, what formula do we use now, Matrix?
A plus B plus C.
That's it, a plus b plus c, and that's equal to the first term of our quadratic pattern. Okay, so now we're going to do a plus b plus c, and it's got to be equal to 5. So now when we go and sub in our a, and we sub in our b, c is now our only unknown, and we can work out what it is. Okay, so c has to be equal to 8. Okay, now they want us, good. Now they want us to write the pattern in the form Tn equals an squared plus bn plus c. All right, so they want us to now write here, I'm just going to do it underneath. We have to write Tn equals, so it's going to be 5n squared minus 8n plus 8. Okay. All right, so here we would have, I would say an accuracy there. Here I would say that would be a CA, and then either an accuracy or a CA mark over there. Okay, next question, 2.3. Which term of the above pattern will be equal to 341? So now what do they want us to do, Matrix? Which term in the above pattern, how are we going to work out? So when they ask us to work out which term, what is the implication? What are we calculating? What letter do they want us to calculate?
I want us to calculate the n.
They want us to calculate the n, and that 341 Kanisile that they've given us, that represents the corresponding Tn. Exactly. Okay, so now we've got to take 341, our Tn, and we need to make it equal to 5n squared minus 8n plus 8. So that'll be at least one of our 3 marks. Because it's quadratic, it means that we need to get it into standard form. So 5n squared minus 8n. And now we've got to take 341 away from 8. So 8 minus 341 leaves us with negative 333. Okay. Now when we get to this stage, I don't know about you guys, but I think that that is an absolute mission to have to factorize. I mean, we can sit around and play on our calculator for a little bit, but really we're wasting time. So what should we use to help us in this situation?
Quadratic formula.
Yeah, the quadratic formula. Okay, and if we use the quadratic formula, we have to show that we've subbed into it. Okay, we absolutely have to show that. So we're not going to write x equals, we're going to write n equals. Okay, because that's what we're calculating. So n equals negative b, so that's negative 8 plus or minus, sorry, b squared. So that's negative 8 squared minus 4 times 5 times negative 333 all over 2, and then a is equal to 5. Okay, and now, sorry, I'm running out of space. We're going to have 2 answers for n. All right, so you're going to work those out, and you're going to tell me what 2 answers for n you got. What answers are you getting for n? Okay, so n equals 9.
Ma'am, I got 9 and minus 7.4.
Okay, all right. So now you got the minus 7.4 when you used the minus instead of the plus, okay, at the front of the formula. Okay, now you have to show both answers. Okay, so your answer there is also could be written as a fraction. It could be written as negative 37 over 5. Okay, now we have to report both those answers because both of them are answers to our question. But in the context of number patterns, n has to be a natural number. So that means that we have to put a line through the equal sign. Okay, and therefore n equals 9 only. Okay, do not make the mistake of just writing down n equals 9. Okay, you've got to say n equals 9 or negative 37,5 and then put a line through the negative 37,5. Okay, very important if you want 3 out of 3. Okay, so your marks here, matrix, would be first of all allocated to, let me just get another pen, would be for equating Tn to the formula, factorizing or subbing into the quadratic formula, and then here for your answer. Okay. How does everybody feel? Does that make sense?
Mm-hmm.
Is that good? Good stuff. Okay, 100%. So now let's go on and have a look at the next question. All right. So the first 3 terms of an arithmetic pattern are 2p minus 7, p plus 8, and 2p minus 1. The first thing that they want us to do is show that p is 12. When we have a question that says show that, what does it mean we're not allowed to do? What are we not allowed to do here? Go for it, Kanyisile. What are we not allowed to do? You're welcome to unmute, Kanyisile.
It means that we're not allowed to use the value that we have been given.
Absolutely, absolutely. So we have to pretend that we do not know that p is equal to 12. All right, so we've got to get to the answer by other means. So what piece of information are we going to use to be able to answer this question? Okay. All right, Kanyisile, you put your hand up again? Go for it. Okay, when you say gather like terms and solve for p, before you even do that, Kaiser.
So, ma'am, what we're going to do is we're going to say p plus 8, put it in brackets, and then we're going to subtract 2p minus 7, also in brackets, and we're going to equate it to 2p minus 1 in brackets minus p plus 8 in brackets.
That's
and
very good.
P.
Absolutely. Okay, so what Kanyisile is explaining really nicely there, what we've got to do is this. We've got to say term 3 minus term 2 is term 2 minus term 1. Or if you want to do it the other way and you've got term 2 minus term 1 is equal to term 3 minus term 2, it means exactly the same thing. All right, it does not matter. Okay, but a subsequent term minusing the previous term. And because our terms, remember, they are all binomials, so that means that we need to use brackets. Okay, so that we remember to remove the brackets and change the signs. Okay, very, very important. All right, so I'm going to say 2p minus 1, And from that, I'm going to subtract p plus 8. Then here, I'm going to start with p plus 8. And I've got to remember to use brackets and put in the 2p minus 7. Okay, very, very important that you use brackets. Okay, now we're going to remove the brackets. So 2p minus 1 will stay the same. That will become a negative, so will that. On this side, p plus 8 stays the same. Then this is going to be minus 2p plus 7. And then as you had said, Kaiser, we need to collect. P is the one side and numbers the other side. So I'm going to leave 2p here. I'm going to bring the minus p down. I'm going to bring that p over from the other side, and I'm going to bring the 2p over from the other side. I'm going to bring down my 8, bring down my 7, bring across my 1, and bring across my 8. Okay, so that leaves us with 2p. Okay, so 2p is going to be equal to 8 plus 7 plus 1 plus 8 is going to leave us with 24. Okay, and dividing both sides by 2, we then get that p is equal to 12. Okay, so that is the correct way in which to set this out. This formula is not on your formula sheets. Okay, not on your formula sheet. So this is a piece of information that you need to know, all right, how you would work out the common difference in an arithmetic sequence. I see people have got their hands up. Yes, Pabalo, go for it. What do you want to ask something? You're welcome to unmute, Pabalo. Let me just send a message. Just give me 1 second, Matrix. Okay, let's go and have a look at the next question. Okay, so we've showed that p is equal to 12. Now they want us to determine the value of the 19th term in the sequence. So how are we going to do that? How are we going to work out what the 19th term in the sequence is? Anyone got any ideas?
So, ma'am, first we'll have to sub in the 12.
Okay.
In order to find out the values. And then we're going to find out the difference between... Yeah.
Okay, so then we'd be able to work out what the difference is if we know the value of the first 3 terms. Absolutely. What else would we know?
And then, ma'am, we're going to use the formula. N is equals to A plus, open bracket, N minus 1, close bracket, constant difference. And then we're going to substitute in the 19 into the... And first, we're going to find the general solution, general something, ma'am. And then we're going to sub in the 19.
Absolutely. So you're quite right. The idea behind this is that we want to work out what the value of term 19 is. So that's A plus N minus 1D when N is equal to 19. So we've got A plus 19 minus 1 times by whatever D is. So we need A and we need D. Okay, just as you had said. All right, so let's go and work out what A and D are. All right, so P is equal to, so term 1 is equal to 2 times 12 minus 7. Term 2 is equal to 12 plus 8. And term 3 is equal to 2p minus 1. Okay, so that means the term 1 is equal to what?
Ma'am, isn't it 17?
It is. For the first one?
Yes.
Yes.
And then 20.
I'm just sending Nelisa a message.
Then
Just give me 1
23.
second. That's right. Okay, so here this would be 20, as you said, and that would be 23. Lovely. Okay, perfect. Okay, so what this tells us, matrix, is that A is equal to, what's A equal to?
3, ma'am.
No.
Back to 17, ma'am.
17, quite right. Okay, so A is equal to 17 and D is equal to 3. Okay, so now we can come along and we can go and sub this in here. So we've got 17 plus 19 minus 1 times 3. Always a good idea to put D in brackets. Sometimes your difference is negative, and then what ends up happening is that you end up subtracting 3 or subtracting whatever it is instead of multiplying it. Okay, good stuff. So 71. Thank you, Boyd Shepherd. That is quite right. Okay, good stuff, everybody. Nice. So now we're going to have a look. Is everybody good? You're all feeling fine? Thumbs ups? Making sense? Good. All right, I'm glad everybody's okay. Oh, good, good. I'm so pleased. Okay, so now they want us to do a calculation, a fairly simple calculation, but normally matrics struggle with sigma notation. Let's see how this one goes. All right, so they want us to calculate the sum of, from n equals 3 to n equals 50 of 3n plus 14. Okay, so when it comes, yes, Kanisile, you're welcome to unmute and ask a question if you want.
Ma'am, can I ask, the 50,
Yes.
what does it usually mean? I get confused.
No, I'm glad you asked, because that was actually what I was going to ask you before I started on the question. The first thing I was going to say to you guys is, what does the 50 mean? And what does the n equals 3 mean? So yeah, I'm asking you. Does anybody know? Kaiser, you've got your hand up. Go for it, Kaiser.
So n equals 3 means when you substitute n, you start substituting from 3. And the last substitution that you'll make is 50.
Oh, Kaiser, that was beautifully said. Well done. Absolutely. Okay, so that's it, Kwanda. Okay, so 50 is the last number that you would sub in. Okay, so Kanisile and anybody else who wasn't 100% sure, you can make a little note of that for yourself. The number at the top, okay, is the last number subbed in. Okay, and when we say subbed in, we mean subbed into our rule. Okay, the number at the bottom is our first number subbed in. Okay, so in other words, they want us to calculate, I'm just going to write down here, the sum of a series. We start subbing in when n is equal to 3, we stop when it's equal to 50, and our pattern is 3n plus 14, which is the nth term of this particular pattern that we've actually been working with. Okay, so now we're not going to get any marks for this, but we've got to work out what the first 3 terms of the pattern are at the very least. So now the first term, we're going to take 3 and we're going to sub in 3 first of all. And then for our second term, we're now going to sub in 4. And then for our third term, we're now going to sub in 5. And then to get the last term in the pattern, we would have subbed in 50. Okay, so the numbers that we are adding together, the first one in this pattern is going to be what? 23, hey? Okay, does it make sense? Can you see this? So it's an indication of where we start and where we stop. Okay, it tells us where to start and where to stop. Okay, what's the second term, Matrix? Indeed, it is. Indeed, absolutely. And then the third term would be 29. And then all the way down, the very last term would be, well done, it would be 164. Okay, so this is an arithmetic pattern, okay, because there is a constant difference of 3. So in other words, A is equal to 23 and D is equal to 3. Okay, so we don't need to work out what all the numbers in between are because now we're going to use a formula. What formula are we going to use? Does anybody know off the top of their head what the formula is? Go for it, Kaiser.
So, ma'am, what we do first is that we'll say like 50 minus 3 plus 1 to get like the number of terms.
Absolutely. So the number of terms is the number at the top minus the number at the bottom plus 1. Very nice. So there are 48 terms in this pattern. Yes, lovely.
Then we'll take like the number of terms and we'll sub it into the SN formula.
Okay, so we're going to say the sum to 48 is, and then we've got to make sure that we use the arithmetic sum formula and not the geometric sum formula. So the arithmetic sum formula is n over 2. Let me just, maybe I should just write it for you quickly over here. So it's this one. So it's n over 2, 2a plus n minus 1 d. Okay, that is your arithmetic sum formula. Okay, so sum to 48 is going to be 48 over 2. 2 times a is 23, plus n minus 1, so that's 48 minus 1 times d. Okay, and now we can pop that into the calculator. Yes.
Can I just find out, would it be an issue to use a plus l in the brackets?
No issue at all.
Yes,
no problem at all. You can use that as well if you want to. Yeah, 100%. Okay, what are you guys getting as an answer? That's it. Okay, 100%. That's exactly what I'm getting to. Okay. Cool. Okay, so as I had said before we even started, something like this is meant to be, you know, fairly straightforward and fairly accessible for everybody. Okay, so just running through it again, remember the number at the bottom is where you start subbing in. The number at the top of the sigma symbol is where you finish subbing in. That's the last number that gets subbed in. The rule is in brackets next to the sigma notation symbol. And when you want to work out the number of terms in the pattern, it's the number at the top minus the number at the bottom plus 1. Okay, and that's sigma notation. Cool. Okay, so we've covered quadratic patterns. We've covered an arithmetic pattern. Let's go and have a look at something else. Okay, so now these two questions are a little bit more difficult. Okay, a little bit more challenging. So the first thing that they're saying to us here is that if t is a real number, show that the following sequence cannot be geometric. How do we even start a question like that? So t is real, but the sequence is not geometric. How would we answer a question like that? What do you think we should do? Okay, but Mr. Bavuma, term 2 minus term 1 equals term 3 minus term 2 is for arithmetic patterns where there's a constant difference. So term 3 minus term 2 equals term 2 minus term 1 is not the correct divide. Okay, Tyler, you're getting a little bit closer. Well, I'm going to show you how you're going to prove that it's not geometric. But we've got to have a starting point. So that's what I'm trying to establish first. So when we have an arithmetic series, we have a constant difference or a common difference. When we have a geometric series, what do we have? We have a constant. A constant what? Constant ratio, exactly. All right. So how do we determine our constant ratio in any geometric series? So how do we determine R? There we go. Okay, so we've got to use division. So term 3 divided by term, so just careful guys, it's term 3 over term 2 is term 2 over term 1. Okay, or if you want to write term 2 over term 1 equals term 3 over term 2, that's also fine. Okay, so now we want to go and sub in. That's fine, Watobe, don't stress. Okay, so term 3 is -1. So we're going to sub that in. Term 2 is -1 minus t. Term 2 is -1 minus t, as we agreed. And term 1 is 3 minus t. Now what are we going to do? Go for it, Watobe.
Ma'am, I think we should do cross multiply.
You are quite right. We should do cross multiplying. Okay, so we want to get rid of our denominators. So we're going to cross multiply. And now we're going to get rid of our brackets by multiplying out. Okay, so we're going to multiply our brackets out. That's going to give us -3 plus t. And that's going to be equal to 1 plus 2t plus t squared. Does that make sense to everybody? Why it would be 1 plus 2t plus t squared? Is that okay? Does it make sense to everybody? So I've just foiled out the brackets. We all good? Okay, all right, lovely. And now that we've done that, what do you think our next step is?
I think you should make everything equal to 0.
You think we should make it equal to 0. All right, so let's do that. So we're going to get it into standard form. So I'll put my 0 over here. I'll put my t squared at the front. Then I've got plus t behind that. And then I'm going to take the 3 over to the other side. So then this is going to give me plus 4. Okay, now just go back and read the question. Are we solving for the value of t? Does this question want us to solve for t?
No.
No. Okay, so the question is not for which values of t is the following sequence not geometric. The question is if t is a real number. Now the emphasis here is on the words real number. Okay, so what are they, when they use the word real, they want us to do an interpretation based on what? What's the implication behind something that's real or non-real? No, not necessarily numbers bigger than 0. So it's a particular section in maths that you would have studied in grade 11 that they still ask in grade 12. There we go, Tyler. Okay, so they're talking about delta. All right, so in other words, they're talking about the discriminant. Oh, hang on a second. Okay, so in other words, this is a question about nature of roots. Okay, good. All right, so if you recall, delta is greater than or equal to 0, then roots will be real. Or if delta is smaller than 0, then roots will be non-real. Now we need to prove that this sequence is not geometric. So what do you think? Oh, and then of course the other thing that we need to know is that delta is equal to b squared minus 4ac. So what are we doing with delta? What are we trying to establish? Yes, go for it, Boichepo.
Ma'am, can't we use the how can I say this the formula where we find the roots, and if it says that it's a math error and it says it's not applicable, then you can prove that it's not geometric.
Okay, so what formula are you referring to exactly?
Negative b plus or minus square root b squared minus 4ac over 2a.
Okay, but now if you use that formula, that means that you are calculating the value of t.
Yeah,
okay, because
yes,
because that allows you to calculate the roots of the quadratic equation, right? We are not calculating the value of t. They didn't ask us to work out what t is equal to. So we're not going to use that. We're going to use the discriminant, okay, which is part of that formula. It's what's inside the root. So in other words, b squared minus 4ac, because that's going to tell us something about the nature of the roots. Okay, so that's why we're using this over here. Okay, the thing that I'm drawing the purple block around. okay, because we're talking about the nature of the roots. So what we're going to do is we're going to go back here and we're going to say to ourselves, this is now in standard form, right? So what's the value of A in this case? A is equal to? So in other words, for delta equals B squared minus 4AC, the value of A is what matrix? Cool, Tisha, that's right. What's the value of B? Okay, B is also equal to 1. Okay, so A is the coefficient of the t squared term. B is the coefficient of the t term, and C in this case is going to be equal to? Is going to be equal to 4. Okay, so now we're going to come along and we're going to sub in here. We've got 1 squared minus 4 times 1 times 4. So that's going to give us 1 minus 16, which gives us negative 15. Okay, so because the roots are non-real, because delta is negative, it means that it cannot be a geometric sequence. Okay, so since delta is smaller than 0, it cannot be a geometric sequence. Okay, does that make sense to everybody? Okay, good. How are the rest of you feeling? Oh, good. Okay, cool. Okay. Okay, glad, Tisha. All right, Mr. Bavuma, what are you asking, ma'am? What if you proven it arithmetical? Okay, but now hang on a second, okay? How would you do that? How would you prove that it's arithmetic? There's no way for you to be able to prove that it's arithmetic or quadratic. Right, because I mean we're just working with letters here. So they would have to give us an instruction. There isn't enough information for us to be able to prove that it's arithmetic or quadratic, and it might not be arithmetic or quadratic either. Okay. All we've been able to establish through nature of roots is that it's definitely not geometric. Okay, so this is the way in which they wanted us to do it. Okay, so yeah, here you can see sequences and series together with nature of roots. Okay, so yeah, a complex question, a level 3 question where it's linking those two concepts together. Okay, so we've got 15 minutes left. Why don't we do a problem solving question? So let's have a look at question number 4. They've given us a series, A plus AR plus AR squared plus whatever, has a sum to infinity equal to 1. Second series, whose terms are the squares of the above series, has a sum to infinity equal to 5/6. Determine the common ratio of the first series. All right, so where are we going to start with this question? Any ideas? Sorry, I'm just clearing some space here so that we can write. Okay, let's go back up. Okay, so starting point. Does anybody have an idea where we can start? What can we write down as a starting point? Okay, so Kayser, what you've got to try and do is read it, all right, and try and make an equation. All right, so when they say to you that a particular series has a sum to infinity equal to 1, what is your sum to infinity formula? Can anybody remember what's the sum to infinity formula? Do you remember that now? Sum to infinity formula. So sum to infinity is a over 1 minus r. That's it. Okay, so if it has a sum to infinity of 1, it means that sum to infinity is 1 is equal to a over 1 minus r. Okay, now what we can do is we can say that that's equation number 1. And if we want to, we can cross multiply and we can make a the subject of the formula. So cross multiplying, this will give us 1 minus r is equal to a. Maybe we should make that number 1 because then at least something is the subject. Okay, so now that's the first bit of information. All right, so in other words, we've dealt with this over here. A second series whose terms are the squares of the above series. So when they talk about our squares, what does that mean? What are they asking us to do to the first series? What does it mean when they ask you to square something in maths? What are they asking you to do? So if I say to you guys, what is the square of 5? What would you do? What is the square of 5? Okay, so when we square something, it means that we're multiplying it by itself, aren't we? Okay, so in other words, 5 times 5. Okay, that's what it means when we square something. Exactly, all right? So now you're going to take each of these terms and you're going to square them. So in other words, the first term of the second series is going to be a times a, which is a squared. The second term is going to be AR times AR. So that's going to be A squared, R squared. The third term is going to be AR squared times AR squared. So that's going to give us A squared R to the power of 4. And so our pattern would continue. And what they're telling us here is that that has a sum to infinity equal to 5 over 6. So again, they want us to use the sum to infinity formula. So sum to infinity is 5 over 6 is equal to, okay, so in this case, A is A squared. How are we going to work out what R is? Remember, R is calculated by dividing term 3 by term 2 or term 2 by term 1, right? So R in this case is going to be equal to A squared, R squared divided by A squared. Okay, so R is in fact R squared for this particular question. Does that make sense to everybody? Are you guys okay with that? Yes, okay. Everybody else? All good? Okay. All right, and now in order to get to our answer, we need to solve simultaneously. Okay, so what we can do now is we can go and substitute. So we've got our 5/6 is equal to a squared. Now remember, a was equal to 1 minus r. So we're going to sub that in and we're going to square it over 1 minus r squared. What's our next step, matrix? Okay, so I can expand that. So I'm going to end up with 5/6 equals, then this is going to give me 1 minus 2r plus r squared all over 1 minus r squared. Now what do I have to do? Tim, you guys are exhausted, hey? I'm going to cross multiply. Okay, to get stuff out of the denominator. Right, I don't need to find an LCD because I'm not adding fractions. Okay, so I suppose you can find an LCD, but it means it's going to be easier for you to cross multiply, Kaiser. Okay, so cross multiply, so that's going to be 5 times 1 minus r squared is equal to 6 times 1 minus 2r plus r squared. Now the question, if we just go back and have a look, they asked us to determine the common ratio of the series. So in other words, the implication here is that we need to solve for. What do they want us to solve for? There we go. Okay, so we are solving for R. Okay, lovely. All right, so now we're going to expand our brackets. Get everything on one side. Sorry, that should be plus. Okay, so 6 minus 5, which would leave us with 1. Okay, and now when we get to this point over here, what are we going to do? We're nearly there, guys. All right, so either factorize or we can use the quadratic formula if we want. Okay, and with a bit of luck, this should factorize. So we would have to have 11r over here, r over there. It's minus in the middle, plus at the end. So it has to be minus 1, doesn't it? Does that make sense to everybody? Okay, or we could use the quadratic formula, absolutely. So our alternative here is to say or r is equal to negative b plus or minus b squared minus 4a. Am I going to run out of space? Hang on 1 second. A, just make that into a proper square. And then C in this case is 1. Okay, so that's our alternative. We've got to show the step all over 2a. All right, so if factorizing is horrible, you can use the quadratic formula, but you've got to show that you use the quadratic formula. Okay, you've got to sub into it. So either r is going to be equal to 1 over 11, or r is going to be equal to 1. Okay, now, is it possible for r to be equal to 1 in a geometric? Well, in a sum to infinity, is r equal to 1? Is that allowed? So, in other words, exactly, it's not allowed. Okay, so in other words, for the series to converge, r has to be a value that is between -1 and 1, doesn't it? Okay, so that means that r cannot be 1. Okay, so r is going to be 1 over 11 only.